Okay, so number 7. We're going to find the radius of convergence for this series. And the way we're going to do that is we're going to use the ratio test. So remember, we want to look at an plus 1 divided by an, absolute value of that, where this guy is an, right? So an plus 1 just means in the formula for an, you stick in an n plus 1 wherever you see an n. So if you do that, you'll get an n plus 1 factorial. But it's n plus 1 factorial squared, so we've got to maybe put brackets around it and then square the whole thing like that. Times x to the n plus 1, filling in right there. Divided by, okay, 2n plus 1. If you distribute the 2, it's 2n plus 2, and then a factorial after that. Does everybody see what I did in that step? So if I plug in an n plus 1 there, I have to distribute the 2 and get 2n plus 2. And then you still have the exclamation point, the factorial outside. That's just an plus 1. We do need absolute values around that. And then divided by an is, oh, that's the same as flipping and multiplying by an. So we get the 2n factorial goes on top then. And then we have n factorial squared. And then the x to the n, all that on the bottom. And then all of that is in absolute values. Okay. So, try to save some space there. Okay. So now let's simplify. It's really important to simplify well here. I'm going to go ahead and just reorganize for now. If I have n plus 1 factorial here, I'm going to put the n factorial right underneath it, and they're both squared, by the way. And then I will simplify. So I didn't do anything to those guys. I just rearranged the multiplication down in the denominator. And then let's go ahead and simplify the x to the n plus 1 divided by x to the n. Does everybody see that that's just going to be x? Because you're dividing like bases, you keep the base, subtract the bottom exponent from the top exponent. So that's going to be x. I'll kind of put that on the end. And then what else do we have? We have the 2n factorial divided by 2n plus 2 factorial. And then all of that is still in absolute values. Although some of it you could bring out of the absolute values if everything but the x if you wanted to. Any questions on what I've done so far? I haven't done much. All I've done is plug in n plus 1 and an plus 1 and an in the formula basically, and then simplify. Okay, well, let's see if I can squeeze it in here. If you think about it, I could rewrite the n plus 1 factorial squared as n plus 1 times n factorial, that whole thing squared. That's the same thing as just n plus 1 factorial squared. And then the 2n factorial I'm going to leave as is. The x, I'll just put that in for safekeeping so I don't forget. And then the n factorial goes down here, squared. And then I'm going to rewrite the 2n plus 2 factorial as 2n plus 1. Well, 2n plus 2 actually, and then times 2n plus 1 is what I meant to say. Let me make some room here. Okay, and then so 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n factorial, like that. And I'm rewriting it like that so I can get some cancellation here. Close the absolute values around that. And oh, okay, so this 2n factorial, there's a bunch of factors in the 2n factorial, will cancel with that 2n factorial. Does that make sense? And then, so that we don't have to write another step, I want to point out that because in here, this is multiplication n plus 1 times n factorial, the exponent of 2 will apply to both the n plus 1 and the n factorial. So that guy is going to be squared, and that guy is going to be squared. Does that make sense, you guys? Because if you're multiplying a product, the exponent applies to, if you're taking a product rather to a power, that power applies to both factors in the product. And then that allows me to do this. That allows me to cancel this guy out, cancel this guy out. And that's the hard part of the problem, because it's going to clean up pretty well after that. So I'm going to pull all the positive factors out of the absolute value so that I only have x left inside the absolute values. And then I just have to not miss anything. I think the only thing left on top then is the n plus 1 squared. And then on the bottom, just 2n plus 2. Times 2n plus 1, like that. Let me pause for a second. Any questions on that? So it's intense on the algebra. There's not a lot of calculus here. We have to take a limit in a second, but there's not a lot of calculus going on. Any questions on any of that? So this is about as, as far as manipulating algebraically, it doesn't get any worse than this, I don't think. And then in order to get convergence, okay, I'm gonna have one of you guys answer this question. In order for this guy to converge, what condition does it have to satisfy by the ratio test? That the limit of it has to be less than 1, right? As n goes to infinity. So the idea is this. For convergence, and it's absolute convergence, but we don't really worry about that too much here. For convergence, comma, by ratio test, we need this quantity here to be less than 1. Well, the limit, I should say, as n goes to infinity, to be less than 1. So the way I write that, you could use the LIM notation, but I'm going to use the arrow notation. So what we need is this guy, n plus 1 squared, divided by 2n plus 1, 2n plus 2 actually, times 2n plus 1. We need that guy. Well, we know that that guy is going to converge to what? Yeah. I'll say more about that in a second. Gosh. I should do it right here. You know what let me make an amendment here. I think the way I showed you in the examples is I did the convergence right here. So I'll stick with that. Now, I'll try and make it look as similar as possible to the examples I did on the videos. So, I mean, if you think about it, if you were to multiply everything out here, you'd get a degree 2 polynomial on top, a degree 2 polynomial on the bottom. But what is the lead coefficient going to be? If you actually do the multiplication, n squared plus 2n plus 1 on top, put the x out, absolute value of x out here. So that would be the what you get if you multiply out the top. On the bottom, what would you get? First, yeah, 4n squared, first outer inner last. That's really the only term that matters because the rest of them are smaller degree. 4n squared, but anyway, plus what? Yeah, plus, yeah, good. Plus 2n plus 4n plus 6n plus 2. Yeah, you're right, you're right. Now, the reason I went ahead and did that is because, yeah, you guys should probably show that work. I was thinking about not showing it, but no, we should show it. And then here you can go right to what it converges to. Because the degree of the numerator is equal to the degree of the denominator, this part right here is going to converge as n goes to infinity to the ratio of the lead coefficients. You can prove that using limits. You could use L'Hopital's rule. You could multiply numerator and denominator by 1 over n squared and then take the resulting limit that way. But if you want to just go right to the result, it's going to be 1 over 4. And then you still have this absolute value of x is really a constant with respect to n. The thing we're taking to infinity, it's a constant with respect to. So it just sticks around. So you get 1/4 times the absolute value of x. And so if I do that in that step, then I don't have to do it down here. And I'll just say we need this. You guys already told me we need this to be less than 1, don't we? That's according to the ratio test. So 1/4 absolute value of x has to be less than 1. And then if you solve this equation, well, you can multiply. I'm going to go sideways here. I'll use the double arrow. So this doesn't, I don't know if you've seen this notation, but if you work a problem sideways and you're talking about an inequality statement, you should use a double arrow to indicate this is what you get after you simplify. Whereas if you work downward, you don't have to put anything. It's just a symbol you put to say, oh, the next step, I'm going to multiply, just write down the next step, and then hopefully it's obvious what you did. Multiply both sides by 4. And then to get rid of the absolute values, if absolute value of x is less than 4, that means x without the absolute values is between -4 and 4. Okay. I'm going to pause for a second. Does that make sense to you? Ask questions if you got them. The only reason I didn't work downward right here is because I'm running out of screen space. So when I use the double arrow, I'm not talking about convergence. I'm just saying, oh, this leads to this, which the arrow means leads to or implies leads to that. Does that make sense to you? Okay, in this problem, you're just asked for the radius of convergence. You're not asked for whether or not it converges at the endpoint, so don't worry about it. So this is an interval. It's in inequality notation, but this is an interval. What's the radius of convergence? What's r? Well, what's the length of the... Good. What's the length of the interval? The length of the interval is actually 8, right? Yeah. But you could just find the length and divide by 2. So go 4, the right-hand end minus the left-hand end. 4 minus a -4, divide by 2. If it's not obvious. I mean, here it's obvious because the center of this thing is at 0. X is right in between -4 and 4. So the radius is 4. But if it's not obvious, you could just take the bigger endpoint minus the smaller endpoint. Get 8 divided by 2, which is 4. And so that's what's going to go in here. So it's actually a shorter problem than when you have to find the endpoints. Yeah, in other words, when you have to find the interval of convergence, I, that may or may not quite be the interval of convergence, right? So you were saved that work of finding out whether or not it converges at the endpoints. What else can I do for you guys? Help me help you. Same section? Find the radius of convergence of the series. You don't have to check the endpoints. This was the one that wasn't cooperating, remember? It's only giving you half a point even though you do it right. But I sent you an email and I said I'd give you full credit at the end after you turn it in. Let's take a look. Okay, I'm just going to give me just a second while I copy it into OneNote. Okay, find the radius of convergence of the series. So same story really on this one. Not as complicated of an AN, so that's good news. So AN, absolute value of AN plus 1 over AN. Okay, I'm only going to show the -1 to the power in one step, and then I'm going to delete it, because when you take it outside the absolute values, -1 to a power is just 1. So you plug in n plus 1 wherever you see an n to get AN plus 1. So on top you get -1 to the n plus 1, x minus 8 to the n plus 1. On the bottom, 8 to the n plus 1. Then you're dividing by AN, so you just, if it's a fraction, if AN is a fraction, flip and multiply. So we're going to get, on the factor we end up multiplying by, we'll get 8 to the n on top. And then -1 to the n, x minus 8 to the n on the bottom. Now we're going to want to simplify. So again, I'm going to leave the -1 to the powers out, because if the absolute values break up over multiplication and division, you can pull out those -1s to the power, take the absolute value, and you get 1. So they're gone. We're not going to mess with them. I am going to take, here's what I'm going to do. To simplify this thing right away, I'm going to go ahead and do this division. X minus 8 to the n plus 1 power divided by x minus 8 to the n. Like bases, keep the base, subtract the bottom exponent from the top exponent. So why don't you guys help me out with this one? What do you get? What do you get for the x minus 8 base? Yeah, the answer was in the question on that one. X minus 8, right? And then in parentheses, I guess, although you may not need them. And then, again, I'm not going to write down the -1 to the power. What about simplifying 8 to the n divided by 8 to the n plus 1? What's going to be left in the denominator, right? And then I think that's it, isn't it? So we handled this guy. Well, let me do a different color. We handled this guy. This guy was gone and left us with just x minus 8 to the n. This guy is gone and left us in the denominator with just 8 to the 1. And I meant to say x minus 8 to the 1 on top. And then, does that make sense to you? Any questions on that? Are we, what am I missing, you guys? Well, yeah, we haven't found the radius yet. Yeah, we got to take the limit of that, but what happened to everything with n in it? Yeah, it all went away. So what's going to be the limit then as n goes to infinity? Just with respect to n, this is a constant, right? So, and by the way, you could think of it as just all over just 8, because you take the absolute value of 8 and you get 8. So, I mean, this is kind of a silly step, actually, when there's no n's there. But what this really means, what we really did right there, was we took the limit as n goes to infinity of x minus 8 over 8, absolute value. And of course, it's just x minus 8, absolute value over 8. Okay, what do we need? We need that to be less than 1 by ratio test. By ratio test. For convergence, we need that guy be less than 1. Okay, how do you solve this sort of inequality? Isolate the absolute value of x minus 8. absolute, multiply both sides by this 8, I should say. And you get 8 on the right side. Absolute value of x minus 8 is less than 8. To drop the absolute values, what do you do? Not that you really need to, because you're just looking for r here. So you can kind of tell what r is right now. It's got to be 8. But let's say you want to get at least the full interval without the endpoint convergence, and you want to drop the absolute values. You could write it like that, right? Absolute value of x minus 8 is less than 8 means x minus 8 is between negative 8 and 8. And then if you add 8, you get the interval of convergence, or at least part of it. We haven't checked for convergence at the endpoints, but if you add 8 everywhere, you get, negative 8 plus 8 is 0, 16 here. Anyway, what's r going to be? It's going to be this number, or you could think of it as the length of the interval, which is 16 divided by 2. That doesn't look very much like an 8, so let me try that again. So r equals 8, and then if you go to, let me switch the share. Oops, wrong thing. It's hard to tell. Here it is, I think. Okay, here it is. Yeah, if you go to the assignment and you stick in 8, it's only going to give you like half credit. So if you look right here, it only gives you half credit. And that's because of the guy who programmed this question, which is me. What I'm doing on all these assignments is I'm taking other people's problems that they've written and I'm adjusting them so that they fit the lecture and they look familiar to you, hopefully. And it takes a lot of time, and sometimes I mess it up because I'm not a programmer. But that's okay. You just, when something like that happens, I'll just add in the points at the end. Anything else I can help you guys with? Sure. So 11.6, number 21. Give me a second here to switch the share. Gotta share them one screen at a time here. I'm sorry, which one did you say? 21. Oh yeah, that's a good one. Instead of writing all that down, I just want to point out what the nth term is. So if you look at the very last term in 21, that's actually the nth term. So I'll just write it this way. The nth term, I'm not writing the sum down, but the nth term turns out to be negative 1 to the n minus 1, okay, times a fraction n factorial on top. And then the 1 times 3 times 5 times all the way to to 2n minus 1 on the bottom. They give you that. They don't tell you it's the nth term, but you can tell by looking at the numerator, because they list out several terms to begin with, starting with 1 in the numerator. So you know it goes 1 and then 2 factorial in the numerator. That's the second term. 3 factorial in the numerator. That's the third term. So you know that this guy, the one with n factorial in the numerator, is the nth term. That's how you can tell. And it's the same directions. Use the ratio test to determine whether this series is convergent or divergent. Okay, I was looking at this thinking there's no way this is going to work. Look, in the formula in the book, that factorial wasn't there. So I just copied it down wrong. This is 21 and it doesn't have a factorial there. So that's my bad. I apologize about that. So let's make some adjustments here But the good news is it's going to make it easier to think about. So that needs to go away. And that needs to go away. Oh, good. That's going to make this so much easier. And then you always proofread it. No matter who you are, you make mistakes. So you proofread it, make sure it all looks okay. So first of all, I'm going to delete this mess over here. Okay. So now let's make sure we have the same thing. This is the correct nth term formula now. And then when you plug in n plus 1, yeah, you get that, and then yes, that looks good. And then we flip and multiply by an. So that should be good as well. So flip and multiply by an, and that looks fine. Good. Now it's going to be way easier, you guys. So I do want to see that trick. Let's drop the -1 to the n and the -1 to the n minus 1. That's gone. But I do want to see the n plus 1 factorial written as n plus 1 times n. And then I'll move the n factorial down here. And then if you think about it, I think now it's so simple we can do it in this step. What's going to go away? What's going to be left after we do the cancellation? Yeah, because on top we have the odd numbers up to 2n minus 1. On bottom we have the multiplied together, and then on the bottom we have the odd numbers multiplied through 2n plus 1, the next odd number up. So all of these will cancel with all of these. This guy, the number that comes before 2n plus 1 down here, will cancel with this guy. And it works out nicely if you copy it down right. So 2n plus 1. And then I made that too long. Okay, hold on to that thought just a second. Is everybody now comfortable with that? I just copied it down wrong and blew it, but that's okay. That's why you double check it. Okay, and then we want to do that, right? So that this guy becomes, I haven't forgotten about your question, but let's finish the train of thought here. So this guy becomes n plus 1 divided by 2n plus 1. And do I really need the absolute values anymore even? So that's all positive. So no absolute value is necessary now because I already got rid of the stuff that might have made it negative. So you can drop the absolute values because that's positive. And then for convergence, what do we need? Well, what does this guy converge to? Yeah, the degree of the numerator is the same as the degree of the denominator. It converges to a half, which is, I mean, there's no x in these problems. This is an 11.6 problem. So there's no doubt here. This converges because it's less than 1. So the series converges by ratio test.